Hello, everybody. Hopefully you can hear me. Give me a confirmation if you can hear my voice. Yes, no? I hope so. Oh my gosh. Yes, good. Awesome. So I'll just wait on this screen for a bit and let people trickle in. Don't forget, fill out the attendance form. Post that in the chat. There's a link in there. You can make sure you fill that out. If you don't fill it out, then we don't know that you attended. You need to attend. I believe it's at least half of our workshops to be considered a member and actually get to vote at the end of the year. So make sure you fill that out. You're going to need a few tools. You're going to need Chromium or Firefox. Really, any web browser will work. At the end, we'll be using Python 3. Most distributions should have Python. Calendly certainly has Python. If you don't have it, don't worry too much. It's more of an optional thing. It's cool. You should have Python, but if you can't get it installed, don't worry. You're still going to be able to do quite a few of the challenges that I have today. And as usual, if you want to install Chromium and Python, do sudo apt update to update your repository lists, and then sudo apt install Chromium Python 3 to actually install those programs. Wait till maybe 6:03, 6:04, let people join. We're expecting a lower turnout today. We know everybody's busy with midterms, but that's okay. I should also mention I'm going to quickly go through another program called Burp Suite, which is pre-installed in Kali. It requires a little bit of setup, which I'm not going to go through. It's mainly just to show you what it can do. If we have time after, I can do some one-on-one and help people get it set up. But if you don't have Burp Suite set up, don't worry. I'm just sort of going to demo it. You'll be able to do 99% of the workshop without it. Give it a minute or two more here. I should also mention this is the beginner workshop for SQL injection. If you're looking for the advanced workshop taught by Alex today, that's going to be on our Discord server. She's doing Docker containers and their exploitation and how you can sort of break out of them. It's a really cool thing. So if you're looking for the advanced workshop, that's where you find it. But if you're a beginner, don't really know much about Docker, don't know much about SQL, this will be a good place to start. We'll go over a few different challenges are related to SQL, sort of what SQL is, and it'll be good, hopefully. Yep, you can use a Chromium derivative as Brave. You really only need a web browser. I just say Chromium because, I don't know, most things have it, and it works pretty well. But yeah, you can use Brave. That should work fine. Oh, yeah, we're getting some spam. Don't click that link. Please don't click that link. All right, it's 6:04. I might get started. Here's your last chance to get this link. I'm only kidding. I think it's probably posted on our Discord as well. But make sure you sign this attendance form. All right, let's get started. First, a few little housekeeping things. Magpie CTF, if you haven't heard, the InfoSec Calgary Club is hosting a CTF in February. We are allowing registration currently, but only for premium members. So if you're a premium member, you can now register for the event and get registered. Here's the link. Here's the Eventbrite. We have it posted in the chat. So what's going to happen is you're going to sign in on Eventbrite and enter all your information, and then we'll send you all of the credentials that you need. When we send you the credentials, it's going to come with a password. When you sign into CTFD for the first time, we're going to ask that you change your password immediately after you sign in. So yeah. And once again, this is only for premium members. So if you're not a premium member and you haven't paid your membership fee, don't even bother signing up, because if we know who's premium member and who isn't a premium member. So if you sign up and you're not a premium member, we'll just ignore you. If you want to become a premium member, I believe you still can. There's some information on our website, infosecucalgary.ca, that will tell you how to do that. So yeah. I should also note that this is premium members now. Later on, I forget the exact dates, we're going to open it up to U of C students and then eventually the general public in the Calgary area. So you will get to register eventually, even if you're not a premium member. We're just giving priority to them first. Next week, we have another speaker series that we're going to do. This is Kathy McDonald. It's going to be, if you didn't attend the last one, it was really, really good and really interesting. So I have a feeling this one's going to be the same. She's going to be teaching practical cybersecurity and cybercrime prevention. Again, this speaker series is only for premium members. So once again, you have to have paid your premium member fee to get access to this speaker series, and they're really good. So I recommend you do it. If you want to find out more, there's a link in chat, or go to infosecucalgary.ca/speakers to find out more information about that. So that's next week. So we won't have any workshops next week. We'll have this speaker series. I think that's it for housekeeping. So I think we can get started on SQL injection. This is really my favorite sort of area of web exploitation. It's really cool. Hopefully you'll learn something. So SQL code injection. So for the outline today, we're going to be going through a few different things. To start off, we're going to do a basic outline of sort of what SQL is, and SQL. I'm going to pronounce it SQL from here on out. I've heard it as SQL, but SQL. We're going to go through this SQL syntax, and we're going to go through sort of what it allows you to do in terms of databases, just sort of to give you a background of what SQL is. If you've never used SQL before, that's totally okay. You'll get a good enough background, hopefully, from this workshop that you'll be able to do some actual injection. That brings us into our next topic, actual SQL injections. You might, if you went to some of our meetings last year, Emily did some XXS injection. There's a bunch of different code injections. We'll be focusing on SQL injections. We'll be doing a bunch of different kinds of SQL injections. We'll talk about some basic SQL injections, just sort of like your cookie cutter, the ones that you'll find that are the most simple. And we'll also do a more difficult one called a blind SQL injection. And that's sort of a little bit more complicated, but still certainly manageable. And then finally, we'll go through some solve automation by writing custom scripts, and how you can write scripts to sort of automate the process of SQL injecting, because you'll realize that SQL injecting, depending on the problem, can get incredibly tedious. And as computer scientists, we like to automate as much as we can. So we'll go through that as well. Okay, so what is a SQL injection? I think I should maybe talk about first what SQL is. So what is a SQL query? SQL is a programming type language that is used to query a database. And when I say query, all I'm saying is it's asking a question to a database. So a database is sort of like an application that stores a bunch of user data in a sort of table format, you'll see later, with rows and columns. When we write a SQL query, we're essentially asking for certain information about the data in our database. SQL is what's known as a declarative language. Normally, when you think of a programming language, you think of while loops, for loops, if statements, etc. But SQL, for the most part, doesn't have that. Instead, you're sort of just asking a question. You're just asking the computer a question in a way that it can recognize, but you're not actually saying how the data is getting brought back to you. You're not like saying, let's loop through something, let's do a for loop. We're not doing any of that. We're just asking a question. So a basic SQL query sort of has this structure here. First, it starts off with the word select. So we're going to select Then we want to specify what columns we want. On the next slide, you'll see sort of what a database looks like. It has rows, rows, and rows, and rows, and it has columns, sort of like a typical table. So we're going to select certain columns from a specific table where some conditions are true. So this is the basic SQL structure. And we'll write some, you'll see that the queries that we write are going to be more or less in this format. Yeah. So let's do some example SQL queries. On the left here, you'll see a sort of a visualization of what a database might look like. We have a table here called users. In users, we have 4 columns. We have ID, we have name, we have age, and we have password. So for example, with ID 0, we have a name called Jack Benson. He's 24, and we have his password as Jack1234. Haley Richard is also 24. That's the password. And Aaron DePoez has an age of 30 and has a password of password123. These are not very good passwords, but that's we can forgive them for now. So this is what our database looks like. Above, we have a SQL query. So if we read through it, section by section, we can see select the name column and the password column from the users table where some condition is true. And in this case, our condition is where the age is equal to 24 years old. So when we apply this query to this database, we can see it translates over to this result where we have the name and the password columns, which we specified here. And where the age is 24, we have Jack Benson. We notice his age is 24. We have Haley Richard. We notice her age is 24. And that's sort of the 2 rows that it selects. So that's sort of how a query works. It's not incredibly complicated. It can get way more complicated when you get into bigger queries, but this is sort of what it looks like. Just before we go any further, there are some good resources we can use. If I go to W3 Schools, has a really good practice for SQL. If you want to do some SQL, if you want to do some practice SQL on your own time, we'll do a few right now. If you do W3 Schools SQL practice, you can see try SQL editor for W3 Schools, and here we go. Let's just restore this. So you can do some practice here. On the right, you can see the database. If I click on customers, it'll show us the customer database, very similar. It's just a table with a bunch of rows and a bunch of columns, categories, etc. Let's focus on the customers table. So here you can actually write your own queries here. So for example, if I wanted to select the customer name from the customers table, and if we look, let's see where the city is Berlin, for example. So we do where city, the city column is equal to, and then we wrap this in quotes, Berlin. And then to end off our SQL statements, we end it with a semicolon like this. So this indicates that this is the end of the line, similar to if you're writing maybe C, C++, or Java. When you end off a line, you use a semicolon. So if I run this SQL query, we found one customer, Alfred's. I'm not even going to try and pronounce his last name. And he has that customer name, and he lives in Berlin. So that's kind of cool. So you can play around with this to sort of get a feel of how SQL works and how SQL queries work. Yeah. So give this a shot. Yep, the links are posted in chat, so click there if you want to give this a try. Anyways. Also, send any questions in chat. I'll try and get to them. If you're confused about any of this, don't worry. Just send me a question, and I'm sure I can help you out. So, why do we? How are SQL queries related to web exploitation? Is the question. As it says here, when you log into a website, what's happening in the back end, in sort of the back end of the server, is it's just running a query and checking your credentials against the database and seeing if it exists. So, for example, if we have this sign-in page here, we have this username field, we have a password field. It's your typical sign-in. For example, if we type in the username Mr. Magpie and the password, you can't see it, but it's 12345, and we click sign in, what's going to happen are these credentials are going to get sent to the website's back end, and it's going to run a query on the database. And this is what one of those queries might look like. So the query looks like this. It has our same format. We have the select from where. So if we do select and we see a star here, what the star means is select every single column in the database. We don't care out which specific one we're looking for. We just give us everything. So select everything from a users table where the username is equal to Mr. Magpie and the password is equal to 12345. You'll notice that the Mr. Magpie and the 12345 are the same things that we input in our sign-in page here. So we'll have a users table, it'll have a username, and it'll have a password, similar to what we have here. This would be username, this would be password, and it would be running this query against the database. And what the backend will do is it will say, okay, did any results get sent back from this? It'll run that query, and if the database returns even a single row, then we know, then the web application knows that yes, there is somebody with that username. Yes, there is somebody with that username and that exact password. And it'll say, okay, therefore, because we have that username and password stored in our database, that means that that person has the correct credentials. Because otherwise, if the username was wrong or the password was wrong or a combination of both were wrong, then it wouldn't log us in because this query would not have returned any results from the database. So that's something to keep in mind. For the most part, with these web apps, if the query returns some results from the database, then you get logged in. So let's continue on. Now for the cool part, for the injection. So when we talk about code injections, and in this case SQL injections, what we're talking about is putting our own code into the code that the backend is actually running. So we're injecting our own code. And when we inject our own code into the backend, we're able to modify the results, the behavior, and more specifically, we're able to modify the results of what the query might return. And as you might realize, if we can modify the results, so like every single time we inject the code, the SQL query runs, and it returns some results, regardless of if we're actually have the right credentials, then we can trick the server into thinking that we are logged into somebody. And this can be kind of dangerous depending on how the server or the website is coded. So here I have some Python sort of pseudocode. This is sort of how it looks, how it might look, and this is how an injection. This is how some injectable code might actually be coded. So I have a variable here called Mr. Magpie. I have the password 12345. This is very similar to this is the same credentials that we were using before. Then what we would do is DB, which stands for our database. We would do database.execute. So execute is going to actually run a query against that database. And then inside this execute function, we're actually going to put the query that we want to run. So select all from users where username equals, and then here is the dangerous part. Right here now what we're doing is we're doing something known as string concatenation. If you don't know what string concatenation is, it's when you have two strings in a programming language and you want to squish them together into one string. You would take the first one, you would do plus, and then the second string, and then they would become one big string that you can use. So in this case, we're saying where username equals the username variable, and where the password is equal to the password variable. And what you'll see is that Mr. Magpie will be put right here in the string, and 12345 will be put right here in this query string. And then that will be the query that will be sent back. And it will be checking to see if the username is Mr. Magpie and the password is 12345. And you'll see soon that this is a naive way of coding this. And this allows for code injection. And we'll show a few of those in a second here. So Now for the actual injection, the actual cool part. So here we have our symbols, the same sign-in. If we use the username, I don't know what this is. Would this be a... I'm blanking on what this is. It's not a semicolon. Sorry, I'm blanking. Attack, I'm going to call it. A quote. No, that's probably better. Quote or 1 equals 1, semicolon, space, tac, space. What you'll see if we use this as the username is it will look like select apostrophe. Thank you. Oh my gosh. We'll see the query becomes select all, everything, from the users table where the username equals the first apostrophe and then the second apostrophe here that we added ourselves. This is essentially saying where the username equals an empty string. It's just immediately closing off that username part. And then we're saying or 1 equals 1. And when we say or 1 equals 1, we always know that 1 equals 1 is true. We know this is going to be true every single time. And then we're going to put our own semicolon to say this is the end of the query. And then we'll have these two dashes. And what these two dashes do are the equivalent of a comment in SQL. So in C++ or C, you would use // to comment something out, to comment out a line. In Python, I think it's the hashtag or the octothorpe. In SQL, it's tac. So what you'll see is that all of the rest of this query, this and password equals 12345 semicolon, this gets commented out. So this, for the most part, the backend doesn't even know what this will exist because it thinks it's a comment. But the interesting thing is we're saying the or the username equals empty. No username is going to equal empty or 1 equals 1. So as long as 1 equals 1 is true, which it will always be because 1 will always equal 1, this query, this where, the condition in the where clause will evaluate to true. And because of that, rows will be returned from the database. And because rows are returned, the application will think, oh, rows are returned. This username must be somebody, even though it's not. We're injecting our own code and commenting out anything that we don't need so that we can break any website, or not any website that uses string concatenation to actually do their backend. Because if we didn't use string concatenation, this wouldn't be possible. But because we're using string concatenation, we can inject our own code. So yep, like I said, because 1 equals 1, the query looks like this. 1 equals 1 will trick the backend into logging us in because it will return some rows, because the condition will implicitly evaluate to true because 1 equals 1. Even if this username equals apostrophe, or this username equals empty string doesn't equal true, this 1 equal 1 will make it true. So hopefully that makes sense. Hopefully you have some background now about how SQL works, what you can do with it, how it's used in websites, and how you can inject it. So that brings us to our first challenge. There is one flag. We have a little bit of a banking website here. So go to this link, this IP with this port 3545. It'll be a banking website, and see if you can use what you just learned to actually break in and get the flag. Yeah, I'll give a few minutes for this. So yeah, links are posted in chat if you're looking for them there. I'll leave this page up. I'll give maybe 5 minutes, maybe 10, depending on how long this will take. But see if you can break in. The other thing, if you're into that, we have some breakout rooms in our Discord server. So if you want to work with somebody, or you're just looking for somebody to talk to, or you're a little bit confused and want some help, some one-on-one help, you can go into the intro breakout rooms. There's 5 of them, and you can get some help or work together. And I'll be monitoring that. I should also mention if you're new, this is your first workshop, any flags you find, you'll find them in the format of UCSec, and then 2 curly braces with some text in the middle. What you do is you can go to our Discord page, our Discord server, and you can DM them to Orchid, our bot, and you can get points and be on the leaderboard that way. Yeah. So let me know if you get the flag. Just post if you got it. Don't actually post the flag, just so I know where people are at. I might go leave this till 6:30 and then I'll move on. All right, I'll give it 1 more minute here and then we'll move on. It'll get more challenging, so if you found that easy, don't worry, it'll get more difficult. Once again, we got a bunch of people in one of the breakout rooms if you want somebody to work with or you just want to hang out. Don't feel shy. Make sure you join. It's a lot of fun to work on this stuff, on these problems with other people. Okay. Cool. So, let's see. Okay, I'll do a quick demo of how to get it, just in case you were stuck. So we go to HTTP 3545. There we go. And so what we can do is we click sign in today. We'll get a sign in page here. If you try and enter a credential, I'm just going to spam some stuff and we sign in. It's going to run that query. It's going to see that nothing's in the database and it's going to say nope. we have an incorrect username or an incorrect password. But what we know, or what we think we know, is this site might be SQL injectable. So what we can do is we can do our apostrophe. Thank you everybody for reminding what that is. I totally blanked. So apostrophe or 1 equals 1. Then we're gonna end that query, space, space, tac, tac, space, space. These two spaces before and after the tac, we found out are very important. And if you don't have them, sometimes your injection might not work. So just for safety, make sure you always do that. Otherwise, you'll bang your head against the wall like we did for a very long time. So let's see if I can make this slightly bigger. Ooh, that's kind of not what I wanted. Okay. And then if we click sign in, it's still going to ask us to fill out a password. Oh, yeah, sorry, Mertizi. Yeah, sorry, I should have mentioned the spaces are what you need. So it's going to ask us to put a password. Because we're commenting out the password part, it doesn't actually matter what we enter. You can enter anything. You can enter a space. But when I click sign in, there we go. We have your account details. We've logged in. But what's kind of weird about this is we're getting everybody's account details. Getting Todd's, Jordan's, Montana's, everybody's. If we scroll all the way down to the bottom, you'll see we have a user called Magpie, and we'll have the flag there. So what's happening in the back end of this code is when you do that injection, what's getting returned by the database is every single person's information. That's stored in the database. And then the web page is then printing it all out to the screen like this. So this, as you can imagine, is incredibly insecure. I have a question here from Azar. He says, there's no user called James, but it did work because 1 equals 1. Yep, so it looks like he tried this SQL injection. So he actually did James, and then, or 1 equals 1. And what you'll see is this will actually work as well. What you might know is any of these will work. You could put anything in here and it'll work. Because this first part, where the username equals DSF, etc., and then the apostrophe will get overwritten by this or 1 equals 1. Because we're doing an or statement, it doesn't matter if the username part isn't true, so long as the 1 equals 1 part is true, which we know it always is, we'll be able to inject. And that is how you do a very simple SQL injection. Don't try this on Facebook. Don't try this on Google. They have for sure patched this. But as some people were talking, there are a lot of websites out there and a lot of not very good coders. So you never know. We don't here at the InfoSec Club, we never condone unethical hacking, but it is something to keep in mind if you're making your own website. Make sure you don't code in these vulnerabilities. It can be really easy to, but there are proper ways of doing it to make sure that this can never happen and you can't just spit out everybody's details. Cool. If there's any more questions, just post them in chat and I'll see if I can get to them. But otherwise, I might continue on. So we have a question here. Could you put the injection on the password and get into a specific account? Theoretically, yes. If I really wanted to get into a certain person's account, I haven't actually tried this. Let's actually try to get into Selma's name, into Selma's account. So if I log out, if I were to do, so it's going to say username equals Selma, and then we're going to do our tick. And then I'm not even going to do the or 1 equals 1. I'm just going to do the semicolon, space, space, tac, tac, space, space. And then I enter whatever I want for the password because this is getting commented out. There we go. And here, we're in Selma's account. So we have Selma's information. Because we had that one or 1 equals 1, it was returning everybody's. But if we only want to specify Selma, we can get it that way. Yes, OSNAP is correct. You can get really, really clever with these queries. Okay, let's continue on. Oh, and yep, they're talking about putting the password in the injection field. That can also work too. Yeah, it depends on how the query is formed. Doing it in the username field is typically what I do because the username is typically processed first in the query, so it has less that it has to bypass if you do it in the username field instead of in the password field. Okay, so moving on, we're going to do some more advanced and SQL injection, and we'll teach you some tricks. One big one is the limit clause. So the limit clause is something that you can just sort of tack on the end of your query. And what it does is it allows you to limit how many results get returned back from the database. Before, when we had this username here, or this query here, and we signed in with that tack or that apostrophe or 1 = 1, we saw that it gave us everybody's it gave us everybody's account. And the reason it did that is because the database gave everybody's, the rows for everybody's account back to the website. But sometimes, if the code is smart enough, it'll know that multiple results have been returned. And in the typical situation, when you have a login page and you log in as a user, typically only one row will be returned, right? Because if more than one rows are returned, that doesn't make any sense because you're only really trying to log in as one user. So if multiple rows are returned, the website might be smart enough to say, wait a minute, that shouldn't have happened, and it'll block you out. And so to actually get around this, we can use the limit clause. So this isn't an example injection. I forgot the comments, sorry about that. But this is what a typical injection would look like. So we have our or 1 = 1, and then right at the very end, after we have all of our conditions in our where clause, we're going to put limit 1. So we're going to limit it to 1 output. So like it says here, this will only return one single row, even if multiple rows are eligible to be returned from our query. And we can use this to bypass that. Oops, somehow multiple rows got sent back and then the website doesn't know what to do. This can help mitigate that issue by limiting it to a certain amount. And 1 is typically what you want to do. So just an example. Here we have that same users column with the ID, name, age, password, and the 3 users. Here we're going to select the name, and we're going to select the password from the users table, and then we're just going to limit it to 1. You'll notice here that because we don't have a where clause, we're not actually constraining, we're not checking any conditions. So theoretically, with this query, without the limit clause, every single row should be returned. Jack Benson should be returned, Haley should be returned, and Aaron Deep should be returned because there's no where clause. But because we're limiting it to 1, we'll see that the result is just Jack Benson, and this can help trick the websites. So yeah, that's something to keep in mind. Here's some example code. This is an actual code, but it sort of gives an idea of what's happening. Here we have the database execution. If we do our database execution of a query, we get the results. So the results is equal to the database. So fetch all the rows that this query returns, and then it's going to do a check. So results currently is a variable that stores every single row. I think it's in a dictionary, in a Python dictionary. So this has every single row that the query returned, and we say if the length of results is greater than 1, then it's going to print error, multiple results are returned, and it's going to exit with an error status. So this is sort of what one of those checks might look like. If we had used a limit sort of option in our injection, then we would the length of results would be equal to 1, and we wouldn't get this error. So we can use the limit clause to trick it. So keep that in mind, the limit clause. Next, the where clause is a little bit more powerful that you might have already seen. I'm just going to go through it quickly. So in the where clause, you might have noticed that you can actually chain lots of different conditions together in an injection to actually specify what data you want. If you've taken, I think it's Philosophy 279, which I think all computer scientists have to take, which is that formal logic course, you'll know all about logic and the and or and not operators. But you can use these to chain together different conditions to really sort of specify what kind of query you want. So for example, if we did the injection, or age is greater than 60, and it's not the case that the GPA is less than or equal to 2.5. If we had some table that had these columns, then it would return everybody whose age is over 60 and has a GPA that's strictly greater than 2.5. So yeah, so just keep that in mind. You can always add more clauses and more conditions to the where clause to really refine the data that you're actually looking for. And one thing to keep in mind is sometimes you will need to guess the column names in the where clause. So in this injection, we had the column name age and the column name GPA. This could be a guess. There are ways to extract this data sometimes, what the actual column names are, but a lot of the time you will have no idea what they are, and you'll need to just guess. Some good guesses are username, password, just because that's typically what people use, or just user, or pass, PASS, that's another one you can try, but sometimes you'll have to guess. And a lot of the times it's just a guess and check until you get it right. So with that in mind, with the limit clause in mind, and with the chaining of where commands, we have our next challenge. So this is the next challenge. It's the same IP address as before, but now the port is 9309. We have that posted in chat. So give that a shot. This one's slightly more difficult than the first one, but not too much more. And there are 2 flags in this challenge, so see if you can get them both. And one more time, we have some people in breakout rooms. Feel free to join. I'll be hanging out in there and seeing how things are going. All right, so I just put the syntax up on the screen. It sounds like some people are getting it. I might give it a few more minutes just to make sure everything's working. To make sure everybody has a chance to get the flag. I'll maybe go till 6:55, maybe a little bit sooner if people seem like they're getting it. But yeah, good luck. All right, I might give it 2 more minutes. Post in chat. Maybe give a 1 out of 10 where you're at, where 1 is that this is really, really easy and you're having no problem with it, or 10, this is really, really hard. If you're still having trouble, let me know. Just post in chat and I can get some numbers of where we're at and see how much time. 1, okay, good. You guys are all SQL injecting experts. Incredible. Okay, I'll go till 6:53 and then I'll continue on and do a demo. All right, you can hear me. Let's do a quick demo of this. Let's go, was it 9309? So, we have the same banking website that we had before. Go sign in today, and we'll get that similar sign-in screen that we're used to. So, what you might be tempted to do is try the original, or 1 equals 1, space, space, tac, space, space, enter anything for the password. And when I click sign in, what you'll see is that, oh no, your login details return multiple results. This should not happen. So this indicates that the backend of this server is doing some sort of check to make sure that the number of results that get sent back from the query is less than or equal to 1. Because if it was greater than or equal to 1, we would have an issue, and we would think, oh my goodness, somebody's trying to break into our account. So what we can do is do our apostrophe or 1 equals 1. And then what we can do is we can limit it to 1 result. Do our colon, space, space, remember space, space, tac, tac, 2 spaces after the fact. Sometimes you need it, sometimes you don't. Do it every time, because if you don't, you might run and hit your head against the wall. And then we can enter anything here and we can sign in. And there we go. So we have your account details and we'll get one of the 2 flags. UCSec, at least you got some results. So there's one of the flags. If you look at the user that we return, we have a username called Magpie. We have an email called I'm the Magpie with a negative balance. We'll see his balance is negative $300. So what this might indicate to you is that there is another Magpie, presumably with a positive balance. So if we try this one more time, we click sign in today and we do our injection or 1 equals 1. We actually don't need this part, but I'm going to add it anyways. And then I'm going to go and. So this is where we have to guess. We don't know exactly how, it's called the schema of the database looks, what the columns look like, what the column names are, what types they are. So we're just going to guess. And because it said balance in the actual web client, we can try balance. And because there was one that had a negative balance, let's assume that there is one with a positive balance. So let's say, and the balance is greater than 0. We end our query, we comment out the rest, and then we do this injection. When we click sign in, there we go. We have another username called Magpie, but what we'll see is his email is the second flag. So there we go. The where clause is really powerful. So there's our second flag. And he has a lot more money than the first one. Doing pretty well for himself. So yeah. Azar, looks like he found a different way to do it. I've never actually tried it this way. Let's give it a shot. So it looks like we can do or 1 equals 1. He's going to limit it to 1. And then he's going to do an offset of 1. Let's try this. And yeah, that looks like that works too. The reason for this is when you do your limit clause, it's going to select the first one. And then when you do the offset one, it's going to move that offset one down and get the second result. If you actually look at the code for this, there's actually only 2 users in this database, the first Magpie and the second Magpie. So the offset one will allow you to get that second Magpie. Yeah, that's how that's done. One other thing I want to mention is some people were having issues and they were trying to inject on the password field. So this field here, actually, let's see if I can go back to the original one. Sorry, I just forget what the 3545, here we go. 3545, that's not it. There we go. And they were trying to inject on the password field instead, because presumably you'd think that would work, right? It's the same sort of injection. So if I type anything in, so let's just do Selma again, that's what they were trying. And when we do our injection, so I'm going to type apostrophe space or 1 equals 1, semicolon, space, space, comment, space, space. And I try and do the sign in here. This actually doesn't work. And this is strange, you'd think, because the concatenation is still happening on the password. Inspect the password field. That's a good point. Anyways, you'd think that this would work as well. I might show this after if you're curious. I can't get it on the screen right now, but what is actually happening in the background here is I'm hashing the passwords before I'm sending them into the database. And if you don't know what hashing is, it's when you sort of give a hash function some text and then it turns it into this long string of sort of random-ish characters. So yeah, it's sort of, it's running a hash function on the password before it gets actually sent to the query. So this injection is first being hashed and then it's being sent to the query. And if you've ever seen a hash, it looks nothing like code. So it turns the injection code into something that can't be used for injection. And that's the reason you can't do it on the password, at least in this case. Because of that, it's likely a good idea to do your injections on the username and not on the password. Hopefully that makes sense. Good. Okay. let's continue on. 7 o'clock, we got good time. Good. So yeah, that's how you do that. So next, my favorite part, and my favorite thing to do with SQL injections are blind SQL injections. And what I mean by blind SQL injections. So what is a blind SQL injection? So a blind SQL injection is an attack on a database where you ask the database strictly true or false questions. And the true or false question essentially is, does our injected query, does our injected code return a result or not? And so we're going to ask these yes or no questions, and we're going to extract information this way. And if it doesn't make sense right away, don't worry. Hopefully after you try it a little bit, it'll make more sense. So yeah, so just know that a blind SQL injection is where you're asking the database a true or false question. And the reason we have to do this is for every single time, for every single challenge before this, when we do our injection, we get all of the account details, and then it spits it out on the screen. So for example, in that last one of the flags was in the email section of the code, of what was returned when we did our injection. So that's not always going to be the case. Sometimes the stuff or the information that you're trying to extract is not just going to be spit out on the screen like it was before. And that's where the blind SQL injection comes in. It's blind because you can't actually get the information that you want, but you can there's still ways of getting it by asking true or false questions. Did the injected query return at least one result, or did it return nothing? So in order to do this, we use a very special clause called the like clause. And what the like clause allows you to do is it allows you to do wildcard matching on a piece of text. And this is very useful for blind SQL injections, and you'll see this in a moment. So here's an example injection that actually uses the like clause. So we have our apostrophe, we have or, password, like, apostrophe, a, and then we have the % symbol here. Normally what we've seen before is when we have our column name in the where clause, we do our column name equals something, or our column name is less than, or our column name is greater than. Now we're just doing our column name, in this case is password, is like, and then some string. Here, what does this % symbol mean? This % symbol is a wildcard, and it represents 0 or more characters. So what we're saying is this injection will return all rows where the password starts with an A. Starts with an A, could just be A, could be AAA, ABB, could be anything, where the password is like A and then some result. So here's just a quick example. We have that exact same users table that we had before with Jack Benson, Haley, and Aaron Deep. If we run this query where we're selecting the name and age columns from this users table where the password is like, pass, and then this wildcard, what will happen is the database will look at each row. It'll say, okay, let's look at Jack Benson. Let's look at his password. Is the password like pass % symbol? No, it starts with a J. It starts with Jack. It's nothing like pass. So this isn't going to be returned. But for Haley, the database will look at her row and it'll say, okay, does this start with pass? Yep, PASS, and then we have the % symbol. The % symbol will represent the word exclamation mark part of this query, and then this will say, yep, that matches our like clause, and it will be returned. So Haley's name and age will be returned, and similar, the database will look at Aaron Deep's, say his age is 30, and it will say, okay, does this one start with pass? Yep, pass, and then we have the WORD123 represents the % symbol. So Azar is asking, what if we only use the % symbol? That's a good question. I'm going to make an educated guess on this, but I'm not 100% sure. I recommend you try it yourself. But it's likely going to be the same as saying or 1 equals 1. It's going to return everything because the % symbol will represent 0 or more characters. That encompasses every single possible combination of strings that exist. The empty string and then every possible combination. That's my assumption. I haven't actually tried that. I recommend you try it yourself and get back to us. But yeah. So that's how the like clause work. Hopefully that makes sense. And this is really useful for blind SQL injections because blind SQL injections are essentially just a guess and check using the like clause. So we keep guessing and adding letters until we extract a completed string. So we would maybe start with, let's say we're trying to extract something. Let's say we have a column called flag, hypothetically, and we have a column called flag, and we're trying to extract the data from that. But we only know if our queries return results or not. This is why it's blind. We could do an injection that says where flag is like a %. So we have a %. It's going to say, does it start with an A and then have something after it? And it will say, nope. If it says no, okay, we try B %. Did that return anything? Nope. We try C %. Did that return something? Yes. That's our true or false question. Yes, it returns something. Therefore, we know that there is some data in the flag column for somebody who has a flag that starts with the letter C. Then we start all over again. This is why it gets tedious. We now go, okay, we do our injection, tack where flag is like, we know it starts with C, so we do C, and then we start again at A. C A %. Does that return something? No. C B %. Does that return something? Yes. Great. That's probably not a word in the English language, but great. Then we start again. C B A %. Does that return something? Yes or no? And we go all the way down until we extract all of the data. So yeah, it's a guess and check using specifically the like clause. So with that in mind, here's the next challenge. It's the same IP, port is 2337, and can you extract the password from a user called Magpie? And remember, our flags specifically, they start with UCSec and they're written in leet speak. And this is going to be really tedious. See if you can do it. We have the links posted in chat. I'll give a bit more time for this one. Maybe give 10 minutes or less, depending. I always overestimate, so I'll give 10 minutes and see if you can get this using a blind SQL injection. All right, so it looks like some people are starting to get it. I might just quickly go through and just get people a little bit of a head start if you're struggling still. They figured out the starting part of it, at least in one of our breakout rooms. So again, make sure you join that. If we go to 2337 and I sign in today, here we have our sign in. It'll say, note, due to budget cuts, some but not all passwords are stored in plain text. Before I was hashing them, now I'm not. So if I do this, or 1 equals 1, my most basic injection, and I sign in, oh, it's getting mad because it returned multiple results again. Forgot about that. Let's see, or 1 equals 1, limit 1. It'll log us in to the user Magpie, but we care what Magpie's password is. So if I go back to here and I do the injection, or the password is like, and then we have some text. Because we're assuming it's a flag, ucsec, open curly brace, %, and then we close off our injection. So this is going to say the password is like the prefix to our information security club flag format, ucsec, curly brace, and then some text, which is something you don't know. And we try this. It's going to log us in. So that means that the password for Magpie, oh, sorry, I should have also done, or, because we're doing specifically Magpie, username equals Magpie, and the password is like ucsec, it'll log us in because the password starts off with ucsec. So the next thing you have to do is try all the different characters. See if you can find the next one. And like I said, because this is logging us in, we know that our password, that like clause, is correct, and we're getting closer to what it actually is. I'll give this another 5 minutes. I know this is tedious, and I know this is a struggle, but don't worry, we'll figure out a way to improve that in just a few minutes. All right, I'll leave this till 7:20, and then I'll continue on. Don't worry if you didn't get it. I'm surprised if anybody gets it. All right, I'll leave it for another minute and let anybody who wants to keep trying, and then we'll continue on. Okay, cool. It actually sounds like some people got it, which I'm a little bit surprised. It wasn't the longest password, but that's okay. So what they did in the breakout room, go to the breakout room, you get a ton of flags because everybody's working together, is they did that injection. They did or username is equal to magpie, and the password is like. They first found the UCSec, then they did this, and then they tested a bunch of different letters and vowels. Sorry, let me disconnect from this. Okay, until they got it. So they started with G, and they eventually got G. When they did G, it logged them in. Oh no! I swear I know how to SQL inject. Let me try this one more time. Oh, that's why. G %symbol. Oh no, it's all falling apart. Sorry, everybody. Let's just make sure this is correct. No. Oh, I have this wrong. UCSec. There we go. So they started with UCSec, and it logged them in. The next thing that they tried, they found G. UCSec started with G, and when you do that, okay, then it logs you in. And then they thought, okay, maybe some leet speak, and they said, okay, UCSec G0, and they kept logging them in. So we're asking these yes/no questions. Is this logging us in, or is this not logging us in? So this is why it's blind, because when we're doing this, we're not actually just getting the flag spat out at us on this account details page. The flag is hidden in the password somewhere. But we are computer scientists. There are better ways to do this. We don't have time for this. We have video games and incredible amounts of assignments that are given to us with online school. We don't have time for this. This takes way too long, especially if this was longer. The actual password is good_job. It took them a little bit of time, but they eventually got it. But imagine if this was like 128 characters. This would take a really long time. So what can we do about that? We use all of our coding knowledge, and we write a script that will do this for us. So I'm going to give you a script. This will automate the blind SQL injection process. I wrote this when I was doing some actual CTFs, and I used this during the CyberSci National Challenge, and it helped us a little bit. So this is a useful script that you can use and modify yourself. What the following script will do is it will automate the blind SQL injection process for you. It's written in Python 3, so you'll need Python 3 to run it. One thing that you have to do is there are 3 variables that you'll have to change for this for the script to work. There's let me just double check here. There's a URL variable that's empty that you'll have to put the URL that you actually want to post the data to. There's an indicator variable, and what the indicator is the text that will show up on the page when you successfully when you successfully inject into the website. So that's the indicator essentially verifies that the database returned yes to our question. And then we have the username, which is the username of the user that you would like to inject on. I might download that as well and quickly go through this. Actually, I might give a few minutes, let people try it out themselves. I'll give maybe till 7:25, 7:26, let people play around with it, and then I'll demo how this script actually works. So download this script, infosecucalgary.ca/static/blind -break .py, a Python script, run it with Python 3, and make sure you change those variables so that it works with whatever website we're using. So try it again on the previous one, this previous challenge, and see if you can do this using the script instead. I'm also very curious about this because this is essentially everybody DDoSing our servers at once. So you are also helping me test the resiliency of the servers that we're using. So we'll see how this goes. But I'll give it a few minutes and see if you can get it with the script. Another thing I want to note is here it says double check where the login form is actually posting to. This might mean actually going into inspect element and inspecting the HTML to see where the URL that form is posting to, that login form is actually posting to. It might not be the page that you're currently logged into. So just keep that in mind. All right, I'll give one more minute and then I'll go through the demo of the script and show how it works. I know it's not very much fun to read other people's code. All right, so I'll quickly go through this script. Some people are having some issues, which is understandable. I'm no master coder, and reading my code is probably not the best documented or the best way to do it, but we'll give it a try. I've already downloaded this, so let's just go back and go back to this website. Okay, here we go. With mousepad. Can I not make this bigger? Oh, geez. There's got to be a way to do this. Sorry, everybody. Editor. There we go. That is very big. That's okay. So here's my Python script, and this is blind break. It's going to allow us to break in. So what we can do is we can type the URL to post the actual injection to. So these are the 3 variables that you can manipulate to change how this script works. So if we go here, you might be tempted to use this as the URL that you're signing into, this IP port 2337 at signin.php. But if we actually inspect this page data, what we can see is that the actual form is actually posting to a URL that goes to account.php. So it's going to account.php. So when you click sign in, the data in here is actually posting to this IP 2337/account.php. And because of this, this is the URL that we want to use in our script. Because we don't want to post to this signin.php, we want to post to the same one that the actual form is posting to. So what we can do is we can paste this in here, and it goes to account.php, and that is our URL. Next, for the indicator, what do we want to use to indicate that we've actually logged in? If I do my login, I have to do a limit here. So if I log in, we get some results back. The indicator is just a piece of text on this page that indicates that we've actually logged in. So in our case, we can use your account details. This piece of text will always show up and will always let us know that we've logged in correctly, and the blind SQL injection returned yes to our yes no question. So we can paste that in here. And then third, the username that we want to look for in Magpie. And right before I run this, I just want to quickly go through. I won't go through it super in detail, but just how this works. First, I have all of the characters that exist that could be in the password or the flag. We have A, B, C, D, the entire alphabet. So it's all the alphanumeric characters, all the numerals here. We have a bunch of different symbols. At the end, we have the underscore that we might have. What it's going to do is it's going to do exactly what you were trying to do when you were doing it by hand. It's going to loop through the characters every single time. It's going to build an injection here. After it builds an injection, and it builds an injection by putting the username, putting the character that we're currently looking at, and then ending it off with this % symbol. It's going to build an injection. It's then going to do a request.post. So we're now going to post this data to that URL, and we're going to post the injection in the username field. We're going to print the result out, and then we're going to, if the indicator is in the response text, so if we've logged in, if that indicator, your account details, is in the response text, then we know that the character that we're currently looking at is part of the result. And then we continue looping until we get everything, until it doesn't change anymore, and we get the result. So let's see. This is small. Let's see if we make this bigger. So if we make this bigger, I have my blind break program here that I've edited and added these variables to. So now, if I go Python 3, make sure you specify Python 3 and not just Python. This is important. And we do blind break.py. We'll see what happens. It's doing all our work for us. Oh, it found a U, it found a C, and we can just sit here and watch it go. And this is a lot faster than doing it by hand. Yes, I agree. This is super cool. I love this sort of stuff. I'll just let this go through. You get the idea though. So by writing these scripts, you can save a lot of time. In a CTF rather than trying to do everything by hand. So yep, so Azar is asking, it's kind of a brute force from a very small dictionary. Yep, that's correct. Because this is a brute force, we're trying every single thing. I'm saying this is kind of like a DDoS, not really, but it's sort of a DDoS because we're sort of pinging the server a bunch of times. So yeah, this is how that script works, and it is sort of like we are brute forcing it. I Pray for Death is asking, would it be way faster if you got rid of all the print statements? Actually, no. If I run this, if I'm hosting my web server locally, so when I'm actually testing the building of these challenges and I host it locally, when I run this script, it'll actually find it in about 2 seconds, because the time for it to actually connect to the server and then respond back to the Python program is incredibly quick, because I'm running on the same computer. The server that this is running on is running in New York. So because it's in New York, it takes a bit of time for it to ping and then get back and then ping. So the amount of time saved by removing the print statements isn't enough to actually make the script any faster. Yep. So there we go. And so when it found that it didn't actually change, it didn't find any more characters, we get done. UC-sec, good job. And we found it really easily just by writing this script. Oops, what did I do? So yeah, that's how you automate it. And feel free to use this script on any CTF challenges. I found this useful multiple times. You can edit it however you want, get rid of whatever you need. The main sort of important part is building the injection, posting, and then checking the indicator. So yeah. If there's any questions about this script, let me know and I can go through it. Yeah, cool. Let's continue on. I don't have too much more. One thing that I did want to quickly go through is a program known as Burp Suite. Kind of has a weird name, but this is a really cool program. It takes a little bit of setting up to do. I'm not going to go through how to actually set it up. I'm just going to quickly demo it, and if you want to set it up on your own time, there's a ton of resources you can use. But what Burp Suite is, it is a program that allows you, it acts as a proxy for your web client. So what that means is whenever your web client makes a request, first it asks Burp Suite to make the request, and then Burp Suite will capture the traffic, and it will hold on to that traffic and not forward it back to your web browser until you've looked at it or edited it or done whatever you want to do with it. This makes it really easy to actually manipulate web traffic, to view web traffic, but what we're kind of looking at is how it allows us to quickly resend post requests. Obviously, that script that I was using was pretty quick. This is a little bit slower, but it'll reduce the need for you to like try and log in. Oh, I have to type a password. Let's type something random. We've logged in. Okay, now we have to go back, and it's all been deleted, and that's really frustrating. So I'm just going to quickly demo how we can do this blind SQL injection using Burp Suite instead. So I've set it up with Firefox, so I have to open Firefox. Let's start a new session here. I'm going to go like this. So then we just open up Burp Suite. That was not what I opened. Here we go. Close, next. And we're going to start Burp Suite, and Burp Suite is going to act as a web proxy for our actual web browser here. So what does this mean? If I go over to proxy, here we'll see that intercept is on. There's this little button. Hopefully you can see this. It might be a little bit small. I don't know if I can make it any bigger, unfortunately. So intercept is on. What this means is when I try and go to this website and I press enter, it's going to hang. But instead, Burp Suite is going to open up and it's going to say, we have a request to this website that I just posted in here. And what I can see, this is what the request looks like. It's a GET request. Here's the user agent. It has all the information. This is what the packet looks like. I can forward this request. And now we're getting the fonts that are on that website. Sure, I'll forward that. And there we go. We forwarded the data back to the browser. Let's sign in today. It's going to ask, let's forward it. Let's forward it. Fantastic. So now we're at the sign in page. The proxy got this data, and now we're going to forward it on. Now what I can do is I can enter one of my injections that I want to use. Let's do the like. So, or username equals, hopefully this works, magpie, and password is like UC-sec %, and then we enter our password, anything we want. I'll just type James, whatever. So there we go. So now we have our injection. When I click sign in, Burp Suite is going to pop up, and here we're going to see our post request to account.php that that website, that sort of URL that we were posting to before. And down below, we'll also see the actual post data. So we'll have username. This is what I typed in for the username. You'll see there's a bunch of different weird sort of pieces here. There's like a %27. There's a %3D. This is just how websites encode these sort of special characters, like the equal sign or the or this bracket here. That's how it looks like. And then we have the password, which I typed in James in plain text, being sent over the wire. But here we have the UCSec, and then we have our % symbol. And so what we can do instead is we can click on, instead of sending this, we can click on action, we can click on send to repeater. And what the repeater is going to do, we're going to light it up here. We can click on the repeater, and what we can do is we can modify this really easily, click send, and then see the response back. So if I click send right now, we're actually going to get an error. We didn't get an error, that's good. If you get an error, you have to go to repeater, follow redirections, and then click always. And that will allow you to do that. So because we were using UCSec, we have UCSec, and then we have %7b, which is the ASCII representation of the curly brace, and then we have %25, which is the ASCII representation of the % symbol. We can type whatever we want in here between that. So now if I put the G, so we're going to test the G, send. Great. So I did send, and what did it give back? The HTML, and we see we have your account details right here. So this was way easier and way quicker than doing it manually by hand. It's not as fast as the script, but it is easier. G, let's try an O or a 0, send. Yep, that let us in, your account details. Let's try something that's incorrect. Let's try an A, GOA, send. Oh, this time we don't get signed in. We say incorrect username or password. So this is just a tool I wanted to show that allows you to manipulate web traffic and send these post requests incredibly quickly and to view them really easily and change them how you want. So for SQL injecting, Burp Suite can be really useful. So yeah, if you have any questions about how to set that up after, I can certainly give you a hand with that. We have a bunch of execs that can help you out with that. So yeah, with that in mind, I just wanted to show you Burp Suite. We have, let's just skip over this. That's the end of the workshop. I have some Pico CTFs that are related. They're pretty similar. They're pretty simple. If you could do the ones before, you could probably do these ones. But what I am giving you is a bonus challenge. So there is a flag in here. It's on the exact same website that the other challenge, our third challenge, was on. This time we want to extract a password from a user called Bertie, B-E-R-T-I-E with a capital B. When you get the password, when you actually get his actual password, wrap it in the UCSec flag format that we normally do. So you'll write UCSec, curly brace, Bertie's password, and then the closing curly brace. One thing you might notice, and I'm just telling you now, the password is hashed in MD5 hashing. So when you get the hash, see if you can reverse it online. And the reason I'm joining this bonus challenge is because this is very similar to how you can actually steal passwords from people. Before I was saying passwords are stored in plain text. A lot of the times that's not true. Passwords a lot of the times are stored hashed. So this one is stored hashed, and see if you can get Bertie's password. Anyway, I'll leave this up for a bit. That's kind of it for me. I'm not sure if there's anything else I need to talk about club related. Make sure you go to the speaker series next week. That's at 6 p.m. You have to be a premium member. Again, Magpie CTF sign up is now available for premium members. So make sure you sign up if you're a premium member and want to participate. And yeah, I think that's it. So I might hang around. I'll leave this slide up for a bit, but I might hang around in the breakout room and see if anybody wants to try this bonus challenge and get the flag and get those sweet points and get up high on the leaderboard. Anyways, this is actually my last workshop for the year. So thanks everybody for paying attention and doing all the challenges. It's been really fun. We have a bunch of really other good workshops coming up, so make sure you attend those. But that's sort of it for me in terms of workshops. So thanks for joining, and I hope you guys have a good day.